This is Floyd's algorithm. Floyd's algorithm to find all pair shortest path for the following graph. This is Floyd's algorithm is a advance of Versal's algorithm. And Floyd's algorithm and advanced algorithm, these are in dynamic programming. In this dynamic programming, each step solution is overlapping. In this Floyd's algorithm, we have to find all pair shortest path. All pair shortest path means from A to B, A to C, and B to A, B to C, C to A, C to B. We have to find shortest path to visit all vertices. First initial step, we have to convert this graph into adjacency matrix. If graph is given, then convert into adjacency matrix, or if matrix is given, then convert into graph. First, total number of vertices is 3. If there are 3 vertices, then size of matrix is 3. And within this matrix, if there are total number of 3 vertices, the size of matrix is 3. And within this, by default, this is A, B, C. This is A, B, C. But we have to find shortest path to visit all vertices. Now, within this A to A, if vertex I to vertex J, if I equal to J, if both are same, then here we have to write I to J equal to 0. If both are same, we have to write 0. If direct edge is there between V of I to V of J, V of I to V of J, if direct edge is there from here A to B, direct edge is there. If direct edge is there, then P of I to J we can write weight. Else, if V of I to V of J, if there is no direct edge, from I to J, then we write P of I to J equal to infinity. These are the 3 conditions. If I equal to J, both are same, then write 0, write weight. If direct edge is there from I to J, write weight, otherwise write infinity. Now this graph we can convert into adjacency matrix. First A to A. A to A means I equal to J, then this is 0. A to B is 4. Then A to C is 11. Next B. B to A is 6. B to B 0. And B to C 2. Next C. C to A is 3. C to B there is no edge. When this is infinity. C to B infinity. C to C 0. This is matrix, adjacent matrix. From graph to matrix is called as adjacency matrix. Now first step 1. Step 1 means that is initial state. If initial state, within this we can assume first vertex as a intermediate vertex, means vertex A as a intermediate vertex. If vertex A as an intermediate vertex means using A we can take transactions, and if using A we can take transaction means first if A is intermediate, then A row will get same value. A itself as an intermediate means first row will get same values. Next A to B edge is there. If A to B edge is there, then maybe we'll get different values for the second row. A to B and A is intermediate means A to B is 6. A to A is 6 and B to B is 0. B to C previous is 2, and using A, B to A to C you can travel, right? But maybe this route will get different value. Previous value is 2. Means within this we have to find distance B to C. Using A. Previous distance B to A. B to A is 6. B to A is 6. and A to C. Distance A to C. A to C is 11. This is 11. If you want to find distance from B to C, then we have to find minimum distance. Previous distance is 2, or distance B to A plus distance A to C. Within this, we have to find minimum distance. Means minimum distance, this is 2, comma 6 plus 11. 6 plus 11. And 6 plus 11 is 17. And 17 is greater than 2. Means here distance B to C we can keep as it is. This is 2. Because 2 is shorter distance. Means we cannot change. These things you can write, or you can write direct. We will get marks 100%. This is 2. Means this value is 2. Next, C. C to A edge is there. Means maybe this row we can get different values. Here C to A direct is 3. Means A is intermediate. C to A to B edge is there. Right? Here we have to find C to B. Previous C to B is infinity. Means we have to find distance from C to B using A. Right? But we are having distance C to A. C to A is 3. And distance A to C. A to B. A to B is 4. And we have to find distance C to B equal to minimum distance. Previous is infinity. Infinity. This is previous is infinity. Infinity, comma distance of C to A plus distance of A to B. We have to find C to B. Means here infinity, and this distance is 3 plus 4. Means distance of C to B equal to 7. Previous is infinity and this distance is 7. Means we can change this value. Right? And C to C is 0. This is step 1. Similarly, you can write step 2 and step 3. In step 2, next vertex is a intermediate vertex. Next vertex A is over. Next B as a intermediate vertex. Means within this step 2, vertex B as a intermediate vertex. If B as a intermediate vertex, using B we can take transactions. Means if A to B edge is there, then maybe first row will get different values. You check within this. Previous step value is, this is step 1 matrix. Means previous plus, no, this is A to A is 0. A to B and B itself as a intermediate. Means this value will get same. Next, A to B, B to C we can travel. B to C's previous is infinity. Means within this we have to find distance A to C. We have to find distance A to C using B. And using B means we know distance from A to B. A to B is 4. A to B is 4. And distance B to C. B to C is 2. And we have to find distance from A to C equal to minimum distance. Previous is 11. 11 comma, this is distance of A to B plus distance of B to C. And within this minimum distance 11 comma, this is 4 plus 2. Means minimum distance is 6. Distance of A to C is 6. Means we can change this value. Previous is 11. This value we can change. This is 6. A. Then B. B itself as an intermediate. B itself as an intermediate means first A is over, then B, B to A, B to A, 6. B to A, B itself as intermediate, B to A, B row will get same values. B to A, 6, B to B, and B to C is 2. Then C to B, C to B edge is there? No. Thus B is intermediate and C to B there is no edge. Means this value will get same. 3, 7, 0. Second, in second step, these two values means row 2 and row 3 will get same values. Next we can change next intermediate state, step 3. We have to solve up to state 3 because total number of vertices 3. If total number of vertices 3 means we have to solve up to step 3. Step 3. In step 3, vertex C as a intermediate vertex. If C as a intermediate means now all are intermediate. If all are intermediate, then we can take distance, find A to B is 6. Using C, 11 plus C to B, edge is there? No. Means first row will get same values. Within this, we'll get first row same values. First row same values means here. This is step 3. In step 3, we'll get same values. First row same values 0, 4, 6. Next from B, B to C edge is there. If B to C edge is there means B to C edge is there, then B row maybe will get different values. B to A previous is direct is 6. B to C, C to A edge is there. Means this one we can find. Previous we have to find distance B to A. We have to find distance B to A using C. Previous distance B to C is 2. B to C is 2 and C to A. Distance C to A is 3. And we have to find distance B to A equal to minimum distance. Previous distance is 6 and 6 plus distance B to C plus C to A. And from this minimum distance 6 comma here 2 plus 3. This is 5. Distance B to A. Distance B to A is 5. This value is 5. B to B is 0 and B to C is 2. You cannot change this value. Next C itself as an intermediate. C itself as an intermediate means this row will get same values 3, 7, 0. This is called as all pair shortest path. Last step means total number of vertices is 3. Means this example you can solve up to 3. Dear students, like and subscribe the channel.